Plastic bins, totes, and dunnage are an integral part of many industries, from auto manufacturing to agriculture. They often get soiled by the materials they're transporting and need to be cleaned before reuse. These parts can be loaded and unloaded from Better Engineering's cleaning machinery using gripper or suction end effectors. Precision sensors, drives, and fixtures ensure a highly repeatable process. Plastic totes are rarely designed with cleaning and drying in mind. They often have features on the bottom and edges that pool water, which is nearly impossible to blow out with traditional drying methods. Plastic parts are also often temperature sensitive, so heated dryers and flash drying methods are far less effective than they are for metal parts. Using robotics, Better Engineering can dry parts by vacuuming out water pools and returning the water back to wash or rinse tanks. For smaller, lighter parts, a robotic arm can quickly pick parts up to dump water out. Both of these techniques prevent the part from carrying water over from one cleaning stage to the next. Preventing such cross-contamination results in better heat and chemical retention in the washer, which lowers chemistry and water costs and lowers energy consumption. It also prevents hot water hazards for operators who may need to handle parts downstream from the washing process. At the beginning or end of a process, a robotic arm is also able to unstack or restack parts for transportation. Better Engineering is often tasked with cleaning parts that have features that are tricky to clean and dry with traditional methods. It may be blind holes, threaded holes, or hidden pockets that are often difficult to reach with static or even mobile spraying and drying nozzles. For smaller, lighter parts, it can be highly effective and economical to have a robotic arm maneuver these features in front of a spraying or drying nozzle, as demonstrated here, for targeted cleaning and drying. This same technique can be used for performing other in-process functions such as deburring sharp edges or flashing, measuring critical dimensions, or verifying features or tracking barcodes with vision systems. The possibilities are endless. Better Engineering is expert at designing conveyance systems to integrate with robotic loading and unloading of parts. Precision sensors, drives, and fixtures are used in combination with a robotic arm and end effector to alleviate the need for an operator performing this repetitive task. Robotics can not only be used to load and unload parts, but to tackle tough cleaning and drying challenges as well. Parts may be immersed in water and dumped out to flush interior passageways unable to be reached by simple spraying. Parts may also have features and holes sprayed with water or blown out with compressed air while stationary, as demonstrated here, or while traveling along a conveyor. This targeted cleaning and drying method is not only effective for cleaning and drying areas that are difficult with traditional methods, but sustainable as well. Targeted cleaning requires far less water and air consumption and can alleviate the need for large pumps, blowers, and heaters. This conserves energy, water, and chemistry, which is great for both your costs and our environment.